Velocity is fundamentally different from speed. While both describe motion, they are distinct physical quantities that we must understand clearly. Let's see this difference in action with a practical example that you encounter every day. Consider a car traveling at 60 miles per hour. If we only say 60 miles per hour, we're describing the car's speed. But if we say the car is traveling 60 miles per hour due north, now we're describing its velocity. The direction component of velocity is crucial because it tells us not just how fast something is moving, but where it's going. Velocity can be positive or negative depending on the direction of motion relative to a chosen reference point. This is a key concept that distinguishes velocity from speed, which is always positive. Now let's look at how we calculate velocity mathematically using the fundamental formula for average velocity. Average velocity equals displacement divided by time. This formula is fundamental to understanding motion. Notice that we use displacement, not distance, in the numerator. It's crucial to understand the difference between displacement and distance. Displacement is the change in position, while distance is the total path traveled. Displacement measures the straight line change from starting position to ending position. Distance measures the total path length traveled, regardless of direction. Let's see this in action with a simple animation that demonstrates how an object's velocity changes as it moves along a line. Watch as this object moves along a line. The arrow represents its velocity vector. Notice how the direction and magnitude can change, demonstrating the vector nature of velocity. Instantaneous velocity is the velocity of an object at one specific moment in time. Unlike average velocity, which looks at motion over a time interval, instantaneous velocity captures the exact speed and direction at a single instant. Mathematically, instantaneous velocity is found by taking the limit of average velocity as the time interval approaches zero. This means we look at smaller and smaller time intervals until we reach a single point in time. On a position time graph, instantaneous velocity is represented by the slope of the tangent line at any given point. The steeper the slope, the greater the instantaneous velocity at that moment. Instantaneous velocity is crucial for understanding objects with changing speeds and directions. A car accelerating from a stop sign has different instantaneous velocities at each moment, and a ball thrown in the air constantly changes its velocity due to gravity. In calculus, instantaneous velocity is calculated using derivatives. The derivative of position with respect to time gives us velocity. This mathematical tool allows us to find exact velocities at any moment for complex motion patterns. A practical example is determining a car's velocity when it passes a speed camera. The camera captures the car's position at a specific instant, and using radar or other technology, it calculates the instantaneous velocity at that exact moment to determine if the car is speeding.